title of the project is Visual Monitoring of Driver and Passenger Control Panel Interaction. In the advanced vehicular technology, here we're going to implement a visual monitoring system of driver and the passenger with a control panel instruction. The control panel instruction will be given to the driver as well as the passenger, and the entire driving system is going to be visually monitored. In this project, the background subtraction algorithm is going to be applied by getting the information from the superpixel segmentation stage. The term superpixel segmentation means in every visual system there will be a RGB stage, that is red, green and blue. While the intensity of the green pixel is increased means it determined as superpixel segmentation, and a manifold generated will be diffusion maps and process handle the large variation in the ant shape. The ant shape of the driver will be processed with the manifold generated. Along with this, the part of the ant which react with the controller of a given gesture. Gesture means the position of the ant. This method relies on the background subtraction algorithm. In this existing system, we are using a single camera which is mounted on the ceiling of the cabin of the driver, which will totally monitor the interaction of the driver, which control the center console. This could be enabled for the full use of the dual view touchscreen for both the driver and the passenger. By this AND reaction, the accurate location will be given as a sample 1, and this accurate sample AND reaction will be manipulated to provide the gesture information, and the AND using control will be determined as the one of the with highest score. The disadvantages of this system is the gesture recognition will be applied in a low light condition, so the visibility of this one will be very low, and the no pixel will be based on this adaptive segmenter for background monitoring. The background will does not have any pixel. To overcome these disadvantages, in our proposed system, we are going to make a computer vision which is based on the vehicle control for driver and the passenger. This computer vision means it helps us to track and detect the control of the driver as well as the passenger. So the control of the vehicle will be given to the driver as well as to given to the passenger. Here, a system-oriented framework will be developed by using the computer vision technology, which help us to be a safer automobile. The main components of the system in environment is a vehicle and driver, the various issue and developing ideas by different developing models. For these main components as well as activity associated with the complex task will help us to make a safe driving. The advantages of our project is the computer vision technology will be a safety one. The traffic signs provide by the drivers with very valuable information about the road in order to making drivers safer and easier. The application of this project is it capturing the state, intent and activity patterns of the driver. so the passenger will know each and every steps and movement of the driver. The software used in this project is MATLAB 2014A MATLAB laboratory, mathematic laboratory, and the tools used in this project is image processing and computer vision. The technique used in this project is the background subtraction. Here the input stream, that input stream will be given to the background subtraction. If the background subtraction will get the input stream and it will send the specified input stream to the AND extraction. Here the AND extraction have different gesture of the driver, and this all gestures will given to the manifold embedding. This manifold embedding will check the gesture of the driver, different gestures of the driver, and again if it is not correct or if it is in a danger zone, it will give a control activated. Otherwise it will directly go to the gesture classification score. Here it will monitor the driver gesture, and it will also go to the interaction location calculation, and by combining this gesture classification score and interaction location calculation, the decision will be judged. Here they using 900 image, 900 gesture of the drivers. The technique used in this project is background subtraction and superpixel cleaning. Superpixel cleaning is nothing but increasing the pixel intensity of the green one. Here it will also allows the foreground object to decay into the background model. In future, we can also increase the gesture position, because in this project they are using around 900 only. In future we can use above 900 to get a better vision of the gesture, as well as we can also use the gesture motion to as well as the hand shape change, like for example swipe to open the sunroof, like that. Another one is possibility should be focused on the safety also. In our future enhancement, we concentrate on the gesture position as well as the possibility of the focus on safety.